Imagine taking just one step onto the surface of Venus. Forget a heroic last stand or a final message to Earth. Before you could even process the alien landscape, you'd be gone. In less than a second, your body would be simultaneously crushed, flash-boiled, and dissolved by the most extreme surface in our solar system. This isn't a slow death. It's a violent, instantaneous erasure. Venus, our so-called sister planet, doesn't just kill you, it annihilates you. So what would that single, horrifying second actually be like? From a distance, Venus looks almost inviting. We call it Earth's twin because it's so similar in size and mass. For centuries, humanity dreamed of what lay beneath its thick, pale clouds, lush jungles, sprawling oceans, maybe even alien cities. But when our first robotic explorers, the Soviet Venera probes, finally broke through that cloudy veil, they didn't send back pictures of a paradise. They sent back a portrait of hell. The dreams of a tropical Venus vanished, replaced by a terrifying reality, a bone-dry volcanic wasteland baked by a runaway greenhouse effect. The planet that shares so much of Earth's DNA turned out to be our polar opposite in every way that matters for life. It's a world where the sky is filled with acid, and the air is so dense it blurs the line between liquid and gas. So how did our sister planet become this twisted, evil twin? To find out, we have to understand the brutal physics of its surface. The very instant you arrive, the atmosphere greets you. But calling it air is an understatement. The atmospheric pressure on Venus is over 92 times that of Earth at sea level. To feel that here, you'd have to dive nearly a full kilometer into the ocean. This isn't a gentle squeeze, it's an explosive compression. That pressure would crumple a titanium spacesuit like a soda can, but without a suit, the force would act on you inside and out. Any air-filled spaces in your body would be the first to go. Your eardrums would rupture, your sinuses would shatter, and your lungs would catastrophically collapse. The pressure difference would be so immense that your rib cage would snap inwards, destroying your heart and lungs in a single brutal crush. This isn't suffocation. You wouldn't have time to feel it. It's pure, mechanical destruction, all before a single second has passed. If, by some miracle, you could withstand the pressure, Venus has another death sentence delivered at the same moment: the heat. The average surface temperature is a staggering 465 degrees Celsius, or 869 degrees Fahrenheit, hot enough to melt lead. The moment you arrive, the heat transfer would be catastrophic. The ultra-dense atmosphere would dump that heat straight into your body. Any exposed skin would suffer instantaneous, full-thickness burns. But the real damage would happen inside. The water that makes up most of your body would flash boil. The fluid in your eyes, the moisture on your tongue, the water inside every cell of it would turn to superheated steam. Your organs would cook from the inside out. This is a near instantaneous thermal execution, happening at the exact same time as the crushing pressure. So, you've been crushed and boiled in the same fraction of a second. But Venus still isn't done. The very air that's crushing and cooking you is also trying to dissolve you. The atmosphere is about 96.5% carbon dioxide, a toxic gas hot enough to melt metal. High above, clouds of concentrated sulfuric acid float. While the thickest acid rain doesn't reach the ground, the entire atmosphere is laced with corrosive compounds. This acid would eat through a spacesuit, burn your skin, and dissolve your corneas. Let's paint the final picture. In less than 1 second on Venus, a force equal to being 900 meters underwater crushes your bones and organs. A temperature that melts lead boils you from the inside out, and a toxic, acidic atmosphere begins to dissolve what's left. There's no single cause of death. It is a total, systemic, and instantaneous failure of the human body. How did Earth's twin become this planetary monster? The answer is a chilling lesson in climate science: the runaway greenhouse effect. Scientists believe that billions of years ago, Venus might have been more like Earth, with liquid water oceans. But Venus is closer to the Sun. As our star grew hotter, the planet warmed, and its oceans began to evaporate. The problem is that water vapor is a powerful greenhouse gas. More water vapor in the air trapped more heat, which made the oceans evaporate even faster. It was a catastrophic feedback loop that became unstoppable. The oceans completely boiled away, wrapping the planet in a thick, heat-trapping blanket. Over time, volcanoes pumped enormous amounts of carbon dioxide into the sky, creating the crushing, furnace-like atmosphere we see today. Venus is a stark reminder of what can happen when a planet's climate spirals past the point of no return. The experience of dying on Venus is a single, overwhelming moment of total annihilation. It's a world so hostile that our toughest robots only survive for a couple of hours, max, and yet we're still drawn to it. Venus is a cosmic laboratory for understanding how planets evolve and what the absolute limits for life are. We are entering a new golden age of Venus exploration. In the coming years, a fleet of new missions, like NASA's Veritas and Da Vinci and Europe's Envision, are heading to our twisted sister. They'll use advanced radar to map its surface and send probes diving through its atmosphere to uncover its secrets. In its horrifying hostility, Venus teaches us to appreciate the delicate balance that makes our own world possible. It's a reminder that a paradise and a hellscape can be separated by a climate pushed too far. What do you think are the biggest mysteries these new missions should solve? Let us know in the comments below. And if you find these trips to the cosmic extreme as fascinating as we do, make sure to subscribe and hit that notification bell.